in terms of the brief from the client for this project, what did that entail, and what is it that they were looking for?
Okay, so basically the brief for the client was to centralize the core component of the building, and that's basically an emergency center distribution point. So you've got a call center within obviously some admin components to that, and then obviously the distribution point of all the ambulances. So previously it was fairly scattered into different venues, and that was now just basically to create one hub where all the parties come together and function from that single space. So that in a nutshell was basically what it came down
to. Good. So how would you say steel played a role in executing that brief, or realizing the vision, the architectural and the client's vision?
Look, so there's various components to it, I suppose. There's more the structural side, and then there's a bit of a decorative side, I suppose, as well. So from the structural side, it's the steel played more a role in terms of the reinforced concrete. So it wasn't a steel frame structure, but rather a concrete frame structure. But I mean, in every type of structure, there is a lot of steel going into it. But I think from this project's perspective, it had more to do with the lightweight facade elements and the roofing component that we brought into the design. So it's not necessarily, like I said, a structural item. It's for me, it was more the decorative side of it. So I can quickly try and walk you through the project, and maybe that will start to explain what we've done. Typically, because you've seen the photos, you've seen basically what we've done in terms of a write-up, and I might be repeating exactly what's in there, but yeah,
not a problem.
I feel that that's basically everything in a nutshell. So maybe I must do a screen share quickly. Okay, and I want to do, let's go to this. So obviously, just to show where we are, you've got Google Earth now. There we go. You've got Google Earth view now. You all see that?
Yeah.
Okay, yeah. So basically, just in terms of where we are, we're based in Port Elizabeth. The project itself is also based in Port Elizabeth. And if I just do a quick zoom in here to the project. So on the right-hand side here, that's basically the project that we're talking about. Closer. So maybe let me zoom out a little bit just to put it in context, and that might make more sense as well. So this entire complex here is the Dora and Ngiza Hospital. It's one of the sort of hospitals in PE. And I think that's also why they thought it was an ideal space for this facility to be operating from. So you've got then obviously a call center in here, you've got the ambulance distribution point, but then the ambulances can come to the hospital directly and then deliver the patients. We've also got a helipad, so everything is now, the entire emergency care system is functioning from here. Okay, so if I go through...
Did you reprimand the kids?
I had to, yes.
The kids.
So I'm going to just share a couple of drawings quickly.
Sure.
So there's basically the same thing. So the site plan, obviously localized to the project itself. If you look here in the corner, that's basically the main site plan of the entire hospital. Let me just zoom in there quickly. So it's quite an extensive site as itself for the hospital complex, and then we obviously just operating from this one corner. So just to, from a highlight perspective, to describe to you what's happening here, you've got obviously your entrance. To the one side, you've got more your staff and public facility. On the left-hand side here, you've got more your emergency facility. So this is very dedicated to all your ambulances. So they will come in and out here, they will be dropping off all the basically the dirty linen and be stocked with all the clean linen. There's a car wash as well. So it's basically servicing of the ambulances after they've been used, and then obviously being dispatched to agencies as the calls come through. This sort of center core here is basically where the call center is. You've got here your sort of atrium space, admin entrance area. You've got some more public spaces here in terms of conference venues and a boardroom. And the front portion here is basically just your admin office spaces. So if we just go to a ground floor plan, there you can basically see, obviously, the colors represent the structures that we're using. So all the green, as you would know, is your concrete frame structure. Red will be your infill brickwork. I'm just going to quickly go through the plans. I think the photos will speak more to what we have achieved. First floor plan. So this is more the medical side, like we said. This is your atrium spaces, your circulation hub, and then on this side you've got your admin spaces. Same thing with your first story. So the first story, the second story is predominantly just your admin block. And then in terms of sections, and this is maybe where it will become more interesting in terms of what we've done with the steelwork. So in terms of the steelwork which we've used here, and I'm just going to zoom into this section. So there's a lot of these shading devices. Now, if we had to do those things in timber, I think it would have been a lot more rough and big and bulky and robust. So the steel elements here just basically allowed us to have these elegant and thin elements to use as shading devices, which I think frames the building quite nicely. There's also then these elements are combined with some walkways. Those walkways are not for day-to-day use. It's purely for a functional use in terms of cleaning the facade, your windows and those elements. Even here on your main section of the building, and I'll get to this in more detail on the photos as well. So again, the same sort of elegant elements, just spanning massive distances. I think this was almost about, I don't want to be incorrect now, but I think it's close to 2.5 or 3 meter span of the shading device. I mean, that you would never have done this elegantly in any sort of other timber conventional structure. And also the eaves, we've basically, so we've got a timber roof structure, but the eaves were extended as a steel element, also just to allow for that thin floating element of the eave, instead of having also a bulky, big sort of rafter type element that couldn't be shaped in an elegant manner. Mm-hmm. And again, the walkway is just on the sides of the buildings. And then another interesting item which you probably have picked up on some of the photos is this is your atrium space. Now, without this massive steel construction here, which in the end appears very elegant, we wouldn't have been able to get this big, vast sort of atrium space. I mean, then there would have maybe been a lot of columns on an array around the building, and you would have just wasted a lot of space. But now we've got the central column, and we call it the Hackspoort. The Hackspoort is actually then carrying this structure above here, which is your concrete roof. And then you've got a bit of a feature element here on top. Unfortunately, this didn't plan out as we would have liked. This was meant to be a skylight, but budget just didn't allow for it. So you'll see in the pictures, we actually tried to mimic a skylight by just having lighting inside of the seating space to create that bit of a halo effect. Even in this section here, so again, we've got a timber roof construction, but the eaves again was extended probably in the region of about 1.5 meters. Also has elegant steel elements, which again, in a conventional rafter, timber rafter situation, you would not have had this opportunity to do these big sort of long extended eaves, and it really came out quite slender and elegant, and I think that's what makes this building. Otherwise it would have been a bland, almost building without sort of contrast and just elements bringing it all together. Okay, elevation wise, so the elevations, let's just have a look here. So this is one of the main elevations which we'll pick up as well. This is where we've got the curved roof. This is where you've got those 3-meter cantilever beams for the shading devices. This building was quite interesting, and I'll get to this portion a little bit later in a bit more detail in terms of the roof geometry. And then over here again, so we've got the shading devices, we've got the covered walkways for servicing all these facades. We've got some decorative pergolas going onto the building, which I think just lends itself to a bit of character to the building. So a lot of the steel elements could be seen as decorative elements, but it does have a functionality behind it as well. Yeah, so this again, this is your main entrance to the back of the building. This is the atrium space, which we'll talk about. That's our curved roof in the background, which is also quite a key design element on this building. And I'll elaborate on that a little bit later as well. So again, on this portion of the facade, again, we've got the shading devices on top here, the steel walkways for servicing of the facade. And again, it just appears very elegant when you look at it on the photos, as opposed to being bulky timber type of construction, or possibly like concrete slabs, which would have, I think, just not give it that same sort of character and feel.
Good. Okay. Emmanuel, any comments or questions from your side so far?
Yeah, Werner, just an interesting question. Is there anything architecturally that you would have done different? I assume this was all designed pre-COVID, in the COVID era.
Yeah, look, this, like I said, this was the design was in 2006. We rolled it out on site late 2015, 2016, if I can remember correctly. In terms of COVID, I think the spaces are actually well planned, as it's big open spaces, so there's a lot of opportunity to have social distancing. The one space that might have been challenging, and maybe I must go to that space quickly, is the control center. So this is basically where all the pools are coming in, and you can see that there the spaces are decent. I mean, there's quite a lot of space between the users, but I think we've also had, and this is a point that I haven't actually touched on, they were also very pro making use of people with disabilities, and that's why you'll see there's actually wheelchairs in here. So they want to promote actually giving guys with disabilities the opportunity to come and work here as call center operators. So maybe in this space we would have had to look a bit more into detail in terms of maybe ventilation, maybe better ventilation. There is a ventilation system as it is, because it is a controlled environment. Nobody, or there's selected people coming in and out only, so it is mechanically ventilated. But perhaps we would have had to do the space planning here a little bit differently, just to accommodate a bit more social distancing between the occupants. But I think in general, the other areas, the offices you can see is quite largely spaced offices. It's individual offices, decent size offices in terms of 16 square meters per office. So I think this building would actually work quite well in the current scenario with the COVID-19 situation that we've got.
Okay, and second question regarding use of steel. Yes? Was there a challenge because the building is curved, either in design, in fabrication, or erection?
I think a little bit in all those points. A curved building is always challenging. I think spatially it's challenging because your walls are not perpendicular to any other wall. I think on site it was also a challenge with setting out and making sure that we keep your grid lines and everything intact. But I must say the contractor has done very well. As part of the roof process, we had a survey done of the roof prior to installing the roof sheeting, and I'll get onto that a little bit later in more detail. And when we overlaid that survey onto the drawings, I think over this entire curve here in the front, there was maybe about, from this point to that point, there was maybe about 60 millimeters difference in terms of what's actually on site and what was actually drawn. And I think that in itself, I must basically congratulate the contractor in achieving that. So that was a challenge. In terms of building and the roof itself, that was a challenge, but we've overcome that, and I think we've actually done very well. But I want to discuss that as a separate point, if you don't mind, Emmanuel. Okay, so the next thing that I was thinking of sharing is just a couple of photos during construction. Very few. There's not a lot of photos. So this basically just shows you the steel framework of the concrete framework. Apologies, of that curved building. Just sort of progress on that same facade. And over here in the corner of this picture, you can actually see how we use the steel as floating elements, just to create those thin and architectural and aesthetic lines onto the buildings. Just again a progress photo of the same view. There's some progress showing the concrete work going up. There was a service core here for lift. There was quite an interesting aesthetical detail here where we've got a skew column. The contractors looked at us strangely, but we persisted and we made it work, and it actually looks very well in the end. So these are just basically duplicate images of what I've got in terms of the professional photos. So this is where we've got also some of those long extended cantilevering brackets with the shading devices, and then on the lower levels we've got the walkways. So this is that main atrium space. So this is basically ground story, first story, second story. So 3 triple volume essentially. Where we've got that massive steel structure holding up the concrete roof. Just a bit of a progress photo of the entire project. There's our nice slanted column. And here you can basically see what we've done in terms of roofing. So we've got the timber construction in terms of roof, your concrete frame structure, and this obviously running all on a radius. So the geometry was tricky getting this to work, but I'll elaborate on that a little bit later. Okay, and it's just that same view from the front. There's our atrium space. So again, I think if we imagine if we had on these sort of grids columns coming down, the space would have looked completely different. So steel definitely assisted us here in terms of just creating this massive open atrium space. During construction, we actually had to fill these columns with concrete as well, and that's just for fire protection to assist with this structure. Okay, this is just a bit of I tried to have an architectural image of the construction work. So this is on the curved roof. This is the sort of extension of the eave. What we've got here. Same photo, just from the opposite angle. And again, so like I said, these things I think wouldn't have been possible if we did it in timber. And if we had it in timber, there would have probably been struts coming down back to the wall. It wouldn't have been this sort of floating and elegant look that we've got here. This was actually meant to be sheeted as well. But with the tapered sheeting that we used, there were certain restrictions. So eventually we only sheeted up to this sort of, call it the parapet line. and the steel structure was cladded with a fiber grate, so also just creating a shading device. And that's essentially what you're looking at. So although it's big sections, I think the span is 3 meters away from the building. I mean, just imagine trying to even achieve that in timber. It would have been literally impossible. Then this is basically the shading, the higher shading device, which we looked at just now in the previous picture. So that's the fiber grating, just creating a different floating element to the roof. These wall as well. This is purely for servicing and access to these windows to clean them. And again, had we used any other sort of material as opposed to steel, it would have been a much more bulkier look and feel to it. You must tell me if I'm going too fast.
All good. Emmanuel, any questions or comments?
With those slanted columns, I just saw the, let's call it slightly challenging formwork. So maybe if you like these slanted columns, the one technology that I've seen used very efficiently at mainland was a concrete fill tube. Since you're using concrete fill tubes anyway, this came out much more economical than concrete slanted columns in those Pretoria projects. So you might copy them. Essentially, what happens is it's a thin-walled tube that's slanted, and it's left there and filled with concrete. So it's actually a very interesting application for a slanted column, because the formwork is so hard.
Yeah. No, I'll definitely look into it.
Struggled.
Yeah. No, definitely.
Yeah.
Okay, just coming back to this over here. And again, even the steelwork in the carports, I think, assisted us tremendously. I think the reason why these look like they're oversized is actually because they are. And again, it's just to facilitate your ambulance vehicles. And again, if we had used anything else, it would have been bulkier. Timber would not have worked here. Your heights was just going to be tremendous. So this actually really came out very nice, very light. Although it's maybe not a light material, I think the end result in terms of what you experience is that it's a very lightweight structure. And then this is the hangar building. I think again, this is basic portal frame construction, but again, it just gives you the open space to provide storage facilities for your helicopter, and then obviously it gives you just the structural strength of maintenance. So this is actually a crawl beam, crawl beam, so they can actually hook up your block and tackle type devices if they have to do maintenance on the helicopter itself. So it forms both a function of just the space and the practicality around how you use the space inside. That's just the hangar from the outside. Okay, that's basically the construction photos. I'm just going to close this here. Let's go to the pre-pictures. Okay, so this is the clicks from the air when it's now finished. So like I said, on the right hand side here, this is more your emergency section. So this is the non-public section. You've got your ambulance drop-off in this area, basically to just restock ambulances, get rid of all the dirty linen and so on. Your ambulance parking base in this area here. Even in this area here, there's a couple of parking bays for the ambulances. And again, it's just showing that although it's a big roof structure, it can be lightweight. Got the hangar here in the back, and then this is our nice curved building where we've got the office facilities. That's the big atrium space building, and then your call center in this sort of node here. Just building from the opposite angle. I think this is maybe where I need to start talking about this curved roof. So the original design showed this roof here actually as a number of conventional roofs made from, let's call it clip block sheeting, and then you would have had to have a lot of valleys. The challenge there also would have been if we had it in that sort of sequence, the building would have had a much more harder and rougher appearance, because you would have had sort of jagged, straight edges, and then you couldn't curve it as nicely as what we've done here. So then we found, obviously, that the zip-tick roof sheeting can be tapered, and that's when we thought, this is actually going to work perfect. So you taper it from the bottom down, it opens up, it's not parallel like your conventional sheeting, and it just offers this sort of seamless curved roof sheet that you would not have been able to do with any other product. And this is for me where the steel actually in this building really comes to play. Is I mean, this we wouldn't have been able to do anything else other than steel. Even if we would have had, yes.
A question for you: Did you have to give them a radius to which to taper, or you adjusted your radius to their taper?
Okay, so what happened was, and it's a good question because there are limitations to this. We obviously designed the building with the conventional type of roof installation, where you had portions of roof with a valley, and then a segment of roof, and then a valley, and then a segment of roof, and then a valley. So we didn't decide on the sheet from the word go. So when we got to site and we had the survey done, because we actually, for accuracy of this, we got a surveyor out. We surveyed the roof trusses after they've been put up, before they manufactured all these sheets, because the sheets is essentially manufactured individually as well. So then we realized that our bottom radius and our top radius is exceeding their limitations. And that's why instead of having the roof coming all the way out here, we had to cut it back to the parapet wall. So there are certain limitations. If you start to narrow at the top and you flare it out to the, if you start to narrow at the bottom, flare it out to the top, obviously the girth of the sheet is limited to a certain width. So yes, there were complications during the construction process, but we have overcome it by changing the way we finish the building slightly. And I think that this is also why we decided to do the survey of the roof, purely because it's so intricate. So we gave Global Roofing Solutions, who was the roofing supplier, we gave them the survey model, and they were able to then put it into their software and actually model their roof sheets on that model, so that we don't have any wastage. I mean, this is a risky item. I mean, if we had dimensions done conventionally, there's always that sort of margin of error that you can get. And I mean, because these sheets are made individually, it's not like the mill comes to site, it rolls out hundreds of meters of sheets. It was very, very individually done. So it basically just eliminated that sort of error factor. So they manufactured the sheets, came to site, and they just installed it, and there was no complications. So that in itself, I think, was a nice team effort, where we made the proposal to the contractor came on board, and we just had it done. And during the process of all these challenges that we had on site, we actually had a very nice team. So from the contractor to some of the metal subcontractors, we had a lot of the times had a lot of coordination meetings in the office where things didn't work out exactly as planned, and we just sat around the table and we made it work. And that's what I enjoy about this sort of project, is where teamwork just comes together and you just make it work. You work together as a team and you finish it as a team.
Good. Werner, we've got about 5 minutes left. I don't know if there's something else that you'd like to just wrap up with, or Emmanuel, if you've got any questions or comments in closing.
Let me just run through the photos quickly. I mean, you've seen these, but I mean, it just shows you that sort of elegantness of the structure. even on these roofs, that's where we had the extended rafter, just to make it float. There again, just gives you that sort of floating element to it. And then just some of the other steel components. I mean, we've got balustrading, we've got these floating elements in terms of the walkway covering. I want to get to the inside quickly. Sorry. There we go. So there's that structural element in the inside, which just opened up this entire space at the bottom. Yeah, then just different applications of steelwork. We've got balustrading, we've got both stainless steel internal, galvanized steel external, some decorative pergolas, all balustrading, and then yeah, the hanger structure and the carports. I think that's my show.
Great, good. Any final comments from you, Emmanuel?
No, it's very nice. I said Werner is exactly the kind of architect who should get more and more into steel, just because he likes all his curved and slanted shapes. It's too bad there's so much concrete there.
Yeah.
Yes. For an architect like you, I think you would really benefit from even more of steel framing, just because this project would have been done very, let's call it, quickly and easily, as compared to, I'm sure the contractor was working hard here.
Yeah, no, they were working on it. There were a few challenges, but yeah, they were working on it.
Yes, good. Nice looking building, and I'm very impressed with that roof. I didn't know they could do that.
Yeah.